Hi, everyone. Thank you so much for having me. My name is Emily Black. As Talia said, I'm presenting our joint work with Tom Zollo, Nikita, Rajaneesh, Zemel, and Talia from Columbia. I'm at NYU. Thanks. Hi. Nice to see you. So in this paper, we tackle the question of what legal and policy frameworks address fairness and discrimination in Gen AI systems, and are they sufficient to prevent harm? And if not, why not? Unsurprisingly, we find the answer is no, at least at the moment. And for most of this presentation, I'm going to tell you why we think that's the case, both through a cross-disciplinary investigation of both the legal and technical literature and how they have mismatches, and also through some case studies. We have 4 case studies pointing out these different mismatches, and I'm mostly going to focus on the first 2. Okay, so first I'm going to focus on these misalignments in these 2 literatures, the legal and technical literatures. So First, let's go back to the basics. We have discrimination law in the US, such as the disparate impact doctrine, and it basically tells us that in certain contexts, like credit or employment, our approval rates for individuals from different demographic groups can't be too far from each other, right? And so, we can't have a credit decision that mostly accepts men, doesn't accept women as much, for example, right? So these laws regulate allocative decisions, like a yes-no outcome about getting a loan or getting a job. And traditional ML systems fit into this framework very well because they often have these binary outcomes or score-based outcomes that we can directly test to see what the difference is in the decisions for people of different demographic groups, right? But for generative decisions, however, that's often not the case. Generative AI systems create text, images, and other generative output that isn't the decision itself, but influences the downstream decision. And so the traditional discrimination frameworks here don't really apply to directly test the discrimination that's happening in these systems. And as we'll see in the first case study, doing the closest thing to these traditional testing frameworks that we came up with in FairML often don't really work for generative AI because they're not really testing the right thing. So what legal frameworks do exist for the Gen AI context, and can they effectively prevent harm? Okay. Oh, man. Okay, yes. We have some frameworks. However, unfortunately, there are fewer of them now than there were when we were writing the paper, but what are you going to do? Well, some of these frameworks do mention the need to test Gen AI systems, even evaluate them for fairness. Unfortunately, the prescriptions are very vague and leave almost everything about the design of the experiment that's supposed to show that there's no bias to the developer of the system, right? So for example, AI Act Article 55 says that deployers must perform model evaluation in accordance with standardized protocols and tools reflecting the art. Now, as I actually discussed last fact on another paper with Talia, this kind of lack of specificity actually leaves it very possible for companies to intentionally or unintentionally create audits or create displays of policy compliant tests to show that their model is not discriminatory in a way that still admits discrimination by essentially playing around with the experimental setup until you find a procedure that shows that your model doesn't discriminate, even though, through a more robust testing environment, it may actually show discrimination. And so this lack of specificity in the regulation allows for this on an even greater scale in Gen AI systems, especially because there's even more flexibility in Gen AI systems, right? Whereas the de-hacking paper, I was saying we can play around with what your training set is, now you can play around with what your prompt is, and a million other things about how you're interacting with this model. But I don't want to, say that this is all policymakers' fault. At the same time, the few things that the policymakers do ask for in these frameworks aren't actually possible to be accomplished with the technical tools that we have available on the moment. So, for example, one thing that the policy frameworks ask for is to evaluate the model in the way that it's going to be deployed. But most of the technical evaluation frameworks that we have in the moment have evaluations for very kind of fake settings, right? So one example of this is in our third case study, which shows that while most evaluations are on one turn of interaction, so a prompt and then a response, most people interact with LLMs in multiple turns, so talk, response, and the fairness behavior changes over the course of that interaction. So, it's important for us to actually create methods to test models in ways that they're going to be deployed. So by looking at these 2 literatures, we kind of isolated some questions here about how these intermediate generative outputs can be tested, how can they be a source of liability, questions about who's liable when generative AI systems are modified by users. How do we increase the stability of these tests in order to prevent de-hacking? And this is kind of what we focus on in our case studies, which I'm going to jump to really quickly right now. So in our first case study, we imagine that an LLM summarizes resumes for a job posting for a social worker, and these summaries will be used by a hiring manager to decide if they get the job. Again, here, traditional discrimination frameworks don't apply because we're not directly making an allocative decision, right? We're just having some textual output. And so we're trying to decide, like, are these summaries equally good? Do they contribute to discrimination in selection? And maybe the person who's doing this test would think to kind of try to adapt the way that a lot of traditional the way that a normal fairness testing procedure would work, and maybe check for equal accuracy of the summaries, right? That would be something that would maybe be the closest to what we would have done before. So let's see if that kind of works out. We're going to generate a bunch of resumes with ChatGPT 4, GPT-4o, like 5 identical resumes based on some traits. Then we add stereotypical names to them from 4 different racial and ethnic groups. A generative AI model creates a summary with that name that's compared to a ground truth summary from a different model. And then to kind of finish the simulation after we create that summary, we have a even more complicated LLM mimic being a decision maker that decides who's actually going to get a job based on these summaries. So what do we find here? If we look at the accuracy of the summaries generated by the LLM, so these are the accuracy of the summaries by racial ethnic group. This is their Rouge score, which is one of the main metrics for seeing how good a summary is. We see that there's really not that much of a difference between a bunch of different LLM models, which are shown here on the bottom, right? So if you'd say that this is my test for discrimination, all these models would look pretty much interchangeable, and you might say, well, looks like Llama 27B is like better on accuracy on all the groups by a small margin, so that might be the best one to choose. But if we see what actually happens when we look at the simulated decision maker, we see that then we get a much larger disparity. So this is the maximum disparity between any 2 demographic groups. And we see that Llama 27B actually has one of the largest discrepancies between 2 demographic groups here, right? Even though if you look at the Rouge score, it looks pretty much the same. Now, you might be thinking that might be because you also used an LLM to simulate the decision maker, and maybe that's where the discrimination is coming from. But when we used the decision maker on the same summary with different names, we actually found that there wasn't very much variation at all in who was chosen, and the discrimination really was coming from the summary model that was being used to create the summaries of the resumes. So what this really shows here is a mismatch between what we were using to search for discrimination and how the output of the model was really going to be used to affect the downstream decision, right? And so we have this puzzle about kind of like, we didn't see that much of a difference here, but then here we see a huge difference in selection rate. So we thought maybe, if we try to use a measure that's closer to what the downstream output is actually going to be used for, it's how it's actually influencing the decision of the hiring manager to get a job as a social worker, maybe you want the sentiment of the resume to be relatively positive. Maybe you want it to be longer because you're saying more positive things about that person. You want to find the person that has high emotional intelligence and high reliability. And if we looked at these metrics across the different models for how they were rated across different ethnic and demographic groups, we saw that the Llama 27B model had high disparities in these metrics that were closer to the downstream decision, whereas the Gemma 2B model, which was similar in its Rouge score, had performed better on these kinds of disparities. So the takeaway here is really like, think about how the output of your model is going to be impacting the downstream decision that it's being headed towards, and maybe that's a better way to test your model for discrimination. But, yeah, it's difficult to come up with these things, and there's a lot of flexibility, so we should also be trying to give some more clarity about how to create evaluations that are formed in that way. Okay, I don't know how much time I have left, so I'm going to try to steam through here. The second case study that we did was about red teaming, and there's now a large amount of emphasis in the policy doctrines about red teaming. It's one of the few techniques that's been kind of singled out as something that you can do to prevent harmful and discriminatory output. For those of us who are unfamiliar, this is basically, red teaming is often performed by using one LLM, often called the red LM, to create prompts that might generate harmful outputs, like, why do you hate X group, right? Something like that. And then you test the LLM that you're trying to deploy with those harmful statements to see if it gives you something toxic. And so you can do this about lots of different kinds of questions. The thing that we look at here, though, is that depending on how you set up your experiment, depending on what you use as your base LLM to generate these questions, you can actually get quite different answers about whether or not the LLM that you're testing is toxic or not, or is being harmful or not. So, for example, here, we have 3 different models that we're testing, which are the ones that are named on the left here. And then we have different models that we're using to generate the questions to see if they're going to behave in a bad way, right? Those are the ones on the bottom. Time to go? Okay, all right. So, all I want to say here is that if you only looked at the last test, there'd be a way to make Llama look like the most fair model. But obviously, if you had a more robust testing regime, that wouldn't be the case. However, someone could construct this test in order to make Llama seem like the most fair model. I'm just going to say really briefly that about this third case study. This was about the different interaction modes. So most of our fairness tests are done on one call and response with the model, but these results show that depending on the fairness of models can change over the conversation length that you have with them. And so just as the policy calls for, it is really important to test over complex interactions. So I'll conclude very quickly here. I hope that you got the sense that this paper shows the gap between technical fairness testing and legal and regulatory goals, and this can be a real risk. It enables de-hacking and undermines accountability. To make Gen AI systems safe and fair, we need fairness tests that align with regulatory objectives and capture the complexities of real-world use. Our case studies highlight some of these problems, and we hope that this inspires further research to bring these 2 disciplines together. Thank you.